Welcome back to our Chem 152 video series. In this video, we'll be talking about how to find the free energy of formation of one piece of a reaction. This question says to find the free energy change for the formation of sulfide 2-. We are given the delta G of formation for silver and silver sulfide. We are also given the solubility product of silver sulfide. In order to begin this question, we must first understand what the solubility product means. Now, the solubility product is another form of equilibrium constant. Now, what the solubility product measures is how favorable it is for a compound to break into pieces. Our first order of business is to write a reaction for silver sulfide breaking into pieces. Let's think about how that would work. We have 2 pieces of silver and 1 piece of sulfide. So if Ag2S breaks, it would break into 2 pieces of silver plus. We'll write AQ, or aqueous, as its state if it does break, plus sulfide 2-, also aqueous. Now, we could write the solubility product as the products divided by reactants. We can write K equals products over reactants. Our products are silver plus and sulfide 2-. We could write Ag plus, and because there are 2 pieces of silver, we would write second power above the Ag. We can also write sulfide 2-. Since there's only 1 sulfide, because there's no coefficient, we can write a 1 above the sulfide. And also, be careful here because our Ag2S is solid, and we have to remember that pure solids and pure liquids are not included in the equilibrium constant. So for our reactants, we just write the number 1. Now, thankfully, we don't really have to do any algebra with this equation because the question gives us the solubility product. We already know that K is going to equal 8 times 10 to the negative 51st power. Very, very unfavorable because this is a very small number. Now, what we can do is find the free energy change for this process of Ag2S breaking into pieces. The equation is delta G standard equals negative R times T times natural log of K. Let's remind ourselves that the R is going to be 8.314 times 10 to the negative 3rd kilojoules per mole Kelvin. The temperature is not given, but since this is standard state, we can safely assume that the temperature is 298 Kelvin. And the K was given to us as well. So all there is to do is to place the numbers in their correct positions. So delta G standard will equal negative 8.314 times 10 to the negative 3rd power times 298 times the natural log of 8e negative 51. Now we can expect, because the K is very small, that the delta G standard will be positive. That is to say, this reaction should be non-spontaneous. Next, we go to a calculator and enter those numbers. When we do so, we'll get delta G standard equals 285.8 kilojoules per mole. Now that we know the energy change for this breaking process is going to use 285.8 kilojoules per mole, we can now do a little bit more math and find the delta G of formation of our missing piece that the question asked for. With this equation, we can set up a table to try to calculate energies of formation for each piece. We'll start with Ag2S, solid. We know that its coefficient in this reaction is 1, and because it's a reactant, we'll say -1. We'll multiply this by its energy of formation, which is given in the question as -39.5 kilojoules per mole. If we multiply together, we'll get +39.5. For silver plus, aqueous, our coefficient here is 2, and it'll be positive because Ag plus is a product. The delta G of formation for Ag plus is also given as 77.1 kilojoules per mole. Multiply this together and we'll get 154.2, also positive. Now sulfide 2-, we know its coefficient is 1 and it will be positive because it's a product. We do not know what the delta G of formation is for sulfide. We'll call that X, and so we'll have 1X for sulfide. Our goal is going to be to try to find what that X is. Now, we found previously that our delta G standard for this entire reaction, that is the total free energy, will be 285.8 kilojoules per mole. Using this information we've gathered, we can find the energy change. We'll set this up and we'll say that our total delta G standard will equal the Ag2S plus Ag plus sulfide. The total delta G standard was 285.8. The Ag2S was 39.5. The Ag plus was 154.2. And we don't know what the sulfide is, but we're just going to have to do some algebra. What we'll do is we'll take all of the terms on the right side and we will subtract them over to the left. This means our 1x is equal to 285.8, subtract 39.5, subtract 154.2. We'll enter this chain into a calculator, and we will get 92.1 kilojoules per mole. This will be our standard free energy of formation, or delta G standard F, of sulfide 2-. So now we've covered not only how to find the free energy of a reaction, but also how to find the free energy of formation of any missing piece we might have. Thank you for watching, and we'll see you again soon.